You have corner office executives staring blankly at a blinking cursor, typing two poorly thought out sentences and expecting the machine on the other end to read their minds. Sending a garbled demand and receiving a flawlessly formatted, completely useless corporate email in return is the defining professional experience of 2026.
Anthropic released raw data proving humans are the weak link in this entire workflow. They analyzed 50,000 distinct user interactions across 3 separate enterprise products. Organizations are abandoning the fantasy of treating AI like a passive search engine. They are engineering it into an automated junior developer. We are pulling from Anthropic's new AI Fluency Index, a May 2026 Digital Jersey Business Seminar, and a technical architecture guide from Hacker Noon mapping this violent shift.
People assume AI capability is a single muscle you flex. You type at the computer, it does the work. The data from those 50,000 sessions across Claude Chat, Claude Code, and Claude Cowork shatters that assumption entirely.
Different products demand distinct signature moves. Claude Chat requires constant iteration. A user sends a prompt, evaluates the output, and refines the request through follow-up interactions. Users who throw one single prompt at the chat window fail across every measured indicator. They demonstrate limited evaluation capabilities alongside zero measurable improvement over time.
Claude Code and Claude Cowork actively punish that chat behavior. They demand extreme goal clarity upfront. You must define the exact objective before the system writes a single line of logic. Users who establish strict boundaries at the outset structure complex tasks effectively. Ambiguity gets eliminated without triggering hallucinated responses.
Users naturally develop what Anthropic calls the description spectrum over time. People figure out how to shape outputs through repeated trial and error. Providing deep context becomes second nature. A new user types a 5-word demand. A user with 3 weeks experience writes 2 paragraphs detailing the target audience and the excluded topics.
They figure out how to ask for things, but they possess zero ability to evaluate what they actually get back. Humans are fundamentally unequipped to supervise these machines. We spent a decade training employees to trust the software on their screens. A calculator never lies. A spell checker rarely fails. We conditioned an entire generation of knowledge workers to assume the computer outputs objective truth. Handing a new employee an AI assistant and telling them to figure it out is like handing a teenager the keys to a commercial airliner and expecting them to learn to fly by playing with the radio dial.
Anthropic's data shows discernment does not develop through passive usage. The teenager presses a button, the autopilot levels the wings. That kid instantly falsely concludes they mastered aerodynamics. People review an AI output, see perfectly formatted syntax, and completely miss the underlying incorrect assumptions. Users blindly accept bad code simply because the indentation looks professional on the surface.
Syntax acts as a psychological trap. A human developer leaves sloppy, variable names or formatting errors when they rush a job. We rely on those visual cues to detect laziness or incompetence. The machine strips away our primary defense mechanism.
AI never gets tired. It always formats its output flawlessly.
Yeah.
Anthropic built a distinct curriculum to force organizations to explicitly teach quality evaluation. You mandate the signature move. You let the description skills develop organically. You block progression until the user spotted the deliberate flaw. Organizations repeatedly hammer discernment into the user's head with manual evaluation checks.
Human discernment is a systemic failure point. Businesses cannot rely on individuals to evaluate AI outputs accurately. We are moving from humans failing to direct the AI to corporations removing the human from the equation.
Nikki Anderson ran a session on May 7, 2026 at the Digital Jersey Hub Academy targeting this exact vulnerability. She instructed organizations to stop using Claude as a simple Q&A engine. The corporate solution revolves around deploying hard-coded skills.
A business creates a custom skill in under 10 minutes to lock in processes and corporate tone. Translating this idea of a custom skill to everyday life brings massive relief. You never have to explain your company's passive-aggressive email tone to a new hire ever again. The machine already knows exactly how much veiled hostility to include in the quarterly update. You encode the exact formatting requirements for a weekly status report.
The AI functions as a constrained, specific task engine before anyone even types a single word. Attendees learn to deploy predefined templates that streamline daily operations. They take rough bullet points from a scattered Zoom meeting. The skill automatically formats those points into 5 perfectly structured Jira tickets. They improved marketing efficiency without writing any raw code. The AI stops being a guessing game and performs specific actions bound by strict organizational rules.
We are removing human error by eliminating human input. If we pre-configure every single interaction, we are locking the AI into rigid pathways. We are building extremely articulate spreadsheets. We restrict the machine to doing the exact same task the exact same way every single time.
The technical architecture making this standardization possible is converging on a single model. Matt Leeds published a Hacker Noon guide breaking open the file system to show how these predefined skills operate. The industry bypassed proprietary interfaces. They settled on a universal .agents/skills directory alias buried directly in the local repository.
Wait, hold on. I need a plain English breakdown of the mechanics when I launch my development environment. I fire up Gemini Code Assist or Claude Code. I need to know how the machine physically locates these rules on my hard drive.
The engine executes a background scan across specific file paths to load capabilities directly into its active context window. This strict hierarchy dictates how the AI discovers its authorized actions. Workspace skills are project-specific. They live at the very top of your root directory. Teams share them via standard Git version control protocols.
So the entire engineering department downloads the exact same AI workflows for local database migrations or pull request review guidelines. A senior developer pushes an update to the repository. Every junior developer's AI instantly inherits the new behavioral constraints.
User skills sit locally in your system's hidden home directory. Those represent global personal configurations. You keep your customized syntax preferences or Docker cleanup scripts isolated out of the shared company repository.
You do not force your personal formatting neuroses onto the rest of the team. Extension skills come bundled directly with third-party plugins like Jira or AWS. They grant the agent immediate read-only access to external APIs without requiring manual token configuration.
The skill.md file acts as both the activation trigger and the execution instruction. Semantic prompt weighting changes how we write logic. The YAML description at the top of the file compiles the behavior. The AI uses semantic vector mapping to match user intent directly to the description.
How does a text description compile logic? Listen, I am used to writing strict deterministic code in Python or C. I define a function. I call the function. I do not format YAML poetry and hope the machine understands my feelings.
You cannot write manages versions as your description. You must write increments the semantic version in package.json when preparing a release. The AI reads that text. It converts those English words into a mathematical semantic vector.
Define a semantic vector for someone who does not have a PhD in machine learning.
The AI plots every concept in a high-dimensional mathematical space. The phrase bump the build sits at a specific coordinate. The description increments the semantic version sits at a nearly identical coordinate. When a user types a vague request, the AI maps that request to this mathematical space.
So it finds the closest matching coordinate. It executes the YAML logic attached to that specific location. You set explicit flags like disable model invocation to true so the AI does not randomly delete active containers while guessing your intent.
You trigger the skill manually. The AI runs a Docker process status command in the background, injects the output into its memory, and logically guides the cleanup operation based on the YAML constraints.
If the AI is constantly reading all this background data, the context window must become overwhelmed quickly.
Context window pruning is an architectural necessity. An AI reading 10,000 lines of AWS CloudWatch logs suffers from lost-in-the-middle syndrome. The model relies on attention mechanisms that heavily weight the beginning and the end of a prompt. The mathematical representation of the middle data degrades.
It forgets the original instructions because it drowned in the middle of a massive log file. Reading 10,000 lines of code is like forcing a human to read a 1,000-page legal dictionary in one sitting. You remember the first chapter, you remember the conclusion. The middle 800 pages turn into an unusable blur.
You write tools that filter and paginate data before returning it to the context window. This architecture raises a severe threat regarding the principle of least privilege. Restricting API tokens and database users becomes a mandatory security requirement.
If the agent hallucinates a drop table command, your database user must lack the physical permissions to execute it. You restrict the environment at the lowest possible operating system level. Giving an agent shell access or database access is a terrifying prospect.
The AI is no longer trapped inside the IDE. Model context protocol servers bridge the physical gap between probabilistic AI and deterministic local scripts. The agent possesses hands.
Giving a machine direct access to modify your file system is equivalent to giving the office intern the master building keys and your personal bank PIN just so they can buy coffee. You want a latte. You hand over the codes to the corporate vault. We are granting excessive, dangerous authority for minor daily conveniences.
The intern might buy the coffee perfectly 99 times. On the 100th time, they accidentally empty your checking account because they misunderstood an instruction about tipping.
Stop and define a model context protocol server. I need the exact translation layer explained.
Large language models operate on probabilities. They generate text based on statistical weights. Local scripts operate on absolute deterministic rules. They execute hard system commands. The MCP server acts as the strict translator between the two environments.
The AI sends a JSON payload representing its desired action. The MCP server validates that payload against strict schemas and executes the local system commands safely.
The Telegram bot Mixie example demonstrates this physical connection. You clone the repository. You install the required dependencies. You inject a Telegram bot token into the agent settings.json file. For Claude Desktop, you edit Claude_desktop_config.json. The AI gains the permanent capability to message the outside world.
Skills do not call each other using hard-coded function pointers. The LLM orchestrates them dynamically based on the skill.md completion protocol. You write plain English instructions demanding the agent invoke the Telegram tool as its final execution step.
The execution loop follows a strict chronological order. The agent initiates the sequence by reading the strict rules encoded in the skill.md file. It digests the boundaries. It uses its built-in file system tools to write the code physically to the disk.
Break down that sequence. I want the exact mechanics of how a text file turns into a pushed production deployment.
The agent scaffolds a React component. The file gets saved physically to the disk before the system hits the observation phase.
It physically checks that the files were created successfully on the local drive. It reads the local directory state to verify its own work.
The tool transition phase activates next. The agent reads the completion protocol. It searches its loaded context window. It locates the external tool matching the description for sending Telegram messages.
It constructs a formatted JSON payload containing the deployment status. The local node script executes that payload. It hits the external Telegram API across the open internet. The delivery hits your physical device.
You experience the visceral panic of your phone buzzing with a Telegram notification from your own laptop. The AI is confirming it just pushed a database migration to production while you were in the kitchen making a sandwich. You gave it a task 3 hours ago. It operated entirely in the background.
We engineered agent skills to have perfect goal clarity and fully automated Telegram reporting. We moved from failing to evaluate a simple chat window to authorizing full autonomous execution loops across our local machines. We started with humans failing to evaluate AI chatbots. We responded to that failure by giving those same bots root access to our file systems and our messaging apps. If we successfully build these agents to operate entirely outside our supervision, at what exact point do the human employees transition from being the directors to merely being the read-only logs the AI occasionally outputs data to?